Okay, people, it's all yours. What do you got? Yes, ma'am.
When we have to use the inside,
Yes.
not just to give you an example.
Sure.
So like, if we have an e to the negative something s. And then it's multiplied by something like that we know, like 1/s or like 1/s minus a or something like that.
I'm making one up.
Yeah, so when you like take the inverse, the cost inverse. You get u of t minus 5. But then that cosine of 3t would become t minus 5.
Yes, exactly that. I make the same shift in the Laplace transform that is given by my Heaviside shift. It's exactly what I do. Now, in this particular example, I pulled 5, so it didn't really help. But in at least one of them, the shift is like pi, right? With a trig function. I can use simplification on the trig functions to make that easier. So I could end up getting rid of it. Like if it was t plus 2 pi inside a cosine, I wouldn't care. Yes, that's how the Heaviside function works. It moves everything over. But that's also why there are two versions of that. Because we can either do the shift here, right? Or if it wasn't shifted, we could shift the other way. The top version is the one we just did. We went from here to here. But this means if I back it up by A, aren't we just going to end up right there? So this is another way to rewrite that shifting. So let's take this same problem. Think about this, right? That's nasty. But I can think of this as the Laplace transform of cosine of 3 times t minus 2. That's my shifting already, right? That's already shifted. So when I go to do this Laplace transform, I'm like, oh, okay. I can think of that as already having the shift in it here. But what if it didn't? The problem is trying to rig the Laplace transform to know what the undo is going to look like. Whoa. So what's the Laplace transform of this? Cosine is the s over s squared plus 9, right? But I've got this t minus 2 thing. That shift, where did I write that? Right, which would be the 2s in this case. But see how that's really the same thing because the shift was already in? How do I write this so it looks like the wrong bit? I don't know how to rig that one in advance. I can't make that one up off the fly. Oh, have me more. Yes, good.
For 7.444, the original equation is times t,
Right.
and then you take is it the inverse that you get capital F?
No, that's when I take the Laplace transform. That's this piece. This is f of s.
So, so then what would how would I solve it for the equals just two? I don't know what F of t is.
Right. So I'm going to end up with some f of s, right? In my result. And I'm going to end up with f of s being something. What did you get for that something?
F of s divided by s minus 2 in parentheses squared.
Right, so I get L of y is f of s over s minus 2 quantity squared?
Yeah.
Okay. So my question is, what do I do with this?
Do you make it into a equal? Like F like what's called
There'll be a convolution here, right? Right. But if I think of doing the inverse transform, right? I can think of this as f of s and then 1 over s minus 2 quantity squared, right?
Yeah.
So I know what the inverse transform of this is. When I do the inverse transform of this, I'm going to get little f of t.
Yeah.
So I'm going to get well, I'll just write it as a convolution. F of t star, whatever the inverse transform of that is.
And that turns into it's TE2T. So
Okay.
I would transform the integral from 0 to t minus c.
Yeah, yeah, absolutely.
I just have to solve.
No, because you don't know what f is, right?
Yeah.
Leave it like that.
Okay.
You could even leave it like this,
Okay.
since we don't know what f is. If I had any more information about what f is, I'd try and solve, but I don't have any information about f. I'm just going to leave my answer is going to have f of t in it. That's an advantage to integral defined solutions, but it's a weird answer. I will give you that.
Yeah.
Excuse me. More questions.
Also a question about the at 7.520 where you have to graph equations.
Okay,
I don't know exactly how to graph like with the U here.
okay. So I can do it on the calculator a lot easier than I can do it in Grapher. So let me show you that here. So what is your equation that you want to graph?
It's e to the negative 3t minus e to the negative t plus e over 2 parentheses e to the negative 3t minus 1.
Say that again. Plus
E over 2
e over 2.
parentheses e to the negative 3t minus 1.
Like that?
Yeah, and then minus e to the negative t. And then u of t of 1.
So all of this is multiplied by that u. Okay. So I have e to the minus 3t minus e to the minus t plus, I got to do some extra parentheses. E over 2, large parenthesis. Now I got to put in all that garbage. E to the minus 3t, that's going to be plus 3, right? And then minus e to the negative t plus 1. And all of that gets multiplied by this u of t minus 1, which turns on at 1. Parentheses. X bigger than 1 is what I want there. Bigger than is here in my test section. Test, whoop, test, bigger than 1. That's my u of t minus 1 for the calculator. So this is going to turn on at 1. I'm not sure I care about it less than 0, but let's only go like from 0 to 5. And this is not going to be all that big. See how I did that sudden jump at 1?
Yeah.
There you go.
No, I just
Or screenshot it if you want to. I know there's a way to do the heavy side function on the grapher. I just don't know what it is. Let's cheat. Let's look that up.
try it. And look, I added like a slider, and I think that was the difference.
Heavy side function Mac grapher. Aha. Same idea. There's an expression, you use x bigger than or equal to, in this case, 1. Right?
Yeah.
So there's my heavy side function made. Or I can do it as pieces. So stop that. Launch grapher. Okay. So if I were going to do this in the grapher, I'd need a piecewise function. So if I go over to the inspector, move this out of the way, I can create a piecewise function like this, but it's only going to have 2 conditions. It's going to have the condition that's just the parts without the heavy side function, e to the minus 3x minus e to the minus x, when x less than or equal to 1, right? And then it'll have the whole thing, e to the minus 3x minus e to the minus x plus parentheses e over 2, close parentheses, add parentheses, e to the negative 3x plus 3 minus e to the negative x plus 1. And we do that when x is bigger than 1. See how it jumps in the middle? Now, I'm pretty sure I made a sign error somewhere because it didn't have a jump the same way. Oh, yes, there's my mistake right there. I have e to the minus 3, not e to the minus 3x. Boink. There we go. And that's the same picture we had.
Yeah.
So I split it into two pieces and I make the change at 1 and I add the part that started at 1 for the heaviside function.
Did you go back to the calculator?
Absolutely. Boink. E to the negative 3x minus e to the negative x plus the e over 2 is in parentheses. Then I have all of this in parentheses, e to the negative 3x plus 3 minus e to the negative x plus 1. And then at the very end, multiply by x bigger than 1.
Weird.
What is your calculator showing you?
It's not that
Ooh. What is it saying?
syntax. Wait, let's go.
Syntax.
It looks, I mean, it looks right. Maybe there's a can't tell. Maybe instead of negative sign, use minus.
I think that's the case in
It's
the
a
negative x one. Yeah. Yep. With the wrong minus signs out there.
Yeah.
There's your graph. Yeah, it's kind of hard to see. The subtraction symbol is 5 pixels wide, the negative is only 3 pixels wide. Really painful to see. And you can see clearly where we came along and went poke and turned something on at time 1. There's our change in continuity. And the same thing shows up in our grapher version, where we actually see the corner much sharper as the gap between the two pieces, right? You came along and did something else right there.
Yeah.
It's still continuous, but it's not differentiable anymore because our function started up. Again, assuming everything else you gave me was right, that's the way you draw the picture.
Yeah.
More questions. For the longest time, I didn't realize that Heaviside was a name of a person. I just thought, oh, no, the function has a light side and a heavy side that turns on over here. No, it's a guy. There it is, Oliver. I want to say Oliver John, Oliver Hibsa. More questions. From 10 on 7. You want to do 9 or 11? Okay. Y prime plus y equals t sine t. And y of 0 is 0. Okay. I do my Laplace transform everywhere. So Ly prime plus Ly equals Lt sine t. Laplace transform of y prime is S L of y minus y of 0 plus L of y equals, all right, t sine t. The extra t is the part that's throwing me, right? Formula number 17. When I have an extra t, I'm going to take a derivative over here. So I should be taking -1 times the first derivative of the Laplace transform of sine t.
Why is it?
-1 to the n.
Okay.
And that's a -1 to the first because it's the first derivative. And I just need, what's the Laplace transform of sine of t? That's 1 over s squared plus 1. So what's the derivative of that? You're going the wrong way. I want the derivative.
That's what I did. -1, so the s squared plus 1 to the -7 times 2s.
And there would have been a -1, but it cancels with that -1. And then over here, y of 0 is 0, so that piece is gone. And I have Ly times s plus 1. Yes? Which gives me the Laplace transform of y is 2s over s plus 1 times the quantity s squared plus 1 squared. partial fractions time. Quite. A over S plus 1, BS plus C over S squared plus 1, DS plus E over S squared plus 1 squared because it's a repeated quadratic factor. Barf. Should be equal to 2S over S plus 1, S squared plus 1. From here on down, there's a crap ton of algebra I'm going to do. Now, best part. I already recognize this as the derivative from here, yes? So whatever I end up with at this part, if I can make it look like this thing, I'm going to get t sine t from it. So I'm going to get something with sine, e to the negative t. I'm going to get something with sine t, maybe also cosine t. And then I'll get something with t sine t and t cosine t, which matches what we would have done if we'd done undetermined coefficients, right? Hot damn, it's going to work. I just got to get the 5 equations in 5 variables first. A S squared plus 1 squared plus BS plus C times S squared plus 1 times S plus 1 plus DS plus E S plus 1. A lot of these are going to be equal to 0 because there's only a 2S on the other side. So it's just going to be a bunch of me figuring out what all the coefficients are. A, S to the 4th plus 2S squared plus 1 plus B, S plus C times S cubed plus S squared plus S plus 1 plus D S squared plus ES plus DS plus E. And I got to multiply that one out, so I got them all together. And that's equal to 2S. We picked the mother of a problem, didn't we? Unfortunately, the worst part about Laplace transfer is doing all the partial fractions. All right, S to the 4ths. I have A plus B, and that needs to be equal to 0. S cubes. I only see these S cubes, is that right? B and C? For S squares, I got a bunch of S squares. 1, 2, 3, 4. So A plus B plus C plus D is equal to 0. And then linear terms. B plus C plus D plus E is equal to 2. B and C and D and E. And then constants, A plus C plus E is equal to 0. Let's make a matrix. It's just easier. A, B, no C's, no D's, no E's equals 0. no A, B, C, no D, no E equals 0. A, B, C, D, no E's equals 0. B, C, D, E, no A equals 2. A, no B, C, no D, E equals 0. Gauss-Jordan time. Second matrix. Create 5 rows, 6 columns. 1, 1, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0. Did I get the matrix in there correctly? 1, 1, all 0, 0, 1, 1, the rest are 1. Oh, no, I didn't. What did I forget? Yeah, I forgot the 2. So let's go back and edit that and put in the 2 over here. Okay, good. I got the 2 in the right place. Matrix, math, reduced row echelon form of matrix A. I hate decimals, math, fractions. A bunch of thirds. A equals negative 2/3. B equals 2/3. C equals negative 2/3. D equals 2/3. E equals 4/3. Okay, so far? Here's the gross part. Laplace transform of y is negative 2/3 over s plus 1 plus 2/3 s minus 2/3 over s squared plus 1 plus 2/3 s plus 4/3 over s squared plus 1 squared. I'm okay with that. Because I know the Laplace inverse of 1 over s plus 1. I'm going to split this into 2 pieces. The s part, 2/3 s, minus the 2/3 1. Then it's this last part. For the moment, we're going to do the same thing. 2/3 s over s squared plus 1 squared plus 4/3 1 over s squared plus 1 squared. Man, that is gross. I know what to do with the first 3. What's this one? This is why we have the formula sheet. Right, because it's s minus negative 1. So it's e to the negative t. Well, that makes sense because it was y prime minus y. I'm sorry, y prime plus y. I should have an e to the minus t. What's this one? And this one is sine. So it's these that I have to kind of manipulate. So these should somehow be t cosine t, t sine t, somewhere in there, right? But I know that when I did the Laplace transform derivative for sine t, I got this extra 2s on top. So I'm looking at that and I'm going, that extra s, I think I need to integrate this and see what it looks like. Same thing here. And see if I can make it the right form for the Laplace transform. All right. So this one should work. As a matter of fact, if I bring the 2 in, that makes that one right away, right? 1/3 2s over s squared plus 1 squared means this should be 1/3 t sine t. It's the other one that's going to be the problem because it's 1 over s squared plus 1 quantity squared. That's going to be the harder one. One over s squared plus 1 squared. I'm For it to be cosine, there should be an s up there. I'm not 100% sure how to undo this one right away. I'm pretty sure there's some algebra I want to do. Let's cheat. Go to the back of the textbook. Go to the back. The very back cover of the textbook has the bigger formula sheet in it, right? So let me take a look there for a second. There's our t sine t one right there, right? There's the t cosine. You see how it's got the s on top? This is the only, that's got an s squared on top. There's the only one without an s on top. And see how it mixes the sine and the cosine together? That's what we need. And our k value is 1, so I'm going to get an extra factor of 1/2 because I don't have the 2 there, right? There we go. Oh, thank God. So, we can bring that 4 in and I can get 2/3 2 over s squared plus 1 squared. And that's what formula is that? That's formula number 25. Write that down, number 25. I get 2/3 sine t plus t cosine t. I'm going to tell you right now up front, I don't think I could have done that without the formula sheet. I would have been stuck on how to do the integral. Hey, I got a sine t. Didn't we have a sine t earlier? From up here? So I can combine my sine t's. I'm sorry, this was the sine t. So I can combine those. Bleh. Hopefully 10 is easier. Teach me to pull a problem I've never done before. More questions, ask me more things.
How'd you spell the matrix multiplier?
Oh, under the matrix button, I want it to do the math. What's the name of the finished function? We do the Gauss-Jordan process. We end at, are you in linear or have you already taken it?
I didn't think.
Oh, okay. So that's the problem. You don't know that name. Reduced row echelon form. Keep going down until you see RREF. That's the thing I want. Hit enter.
Yep.
And then tell it what matrix you want to use. So go back to the matrix button and tell it we're going to use matrix A. Yeah. Oof. Now the problem with that one is it gives me all the decimals. So I told it using the math button to convert everything to fractions. But that's because I like fractions. I'm going to need some more linear algebra stuff in the next couple of weeks. I'm going to beat you up on it. So time to go see the linear tutor. Cody, that's also because I'm a lazy SOB and I absolutely do not want to solve 5 equations and 5 variables by hand.
Yeah, that was going easier.
Ask me more things. I'm not gonna nail you to the chairs. I got nowhere else to be for a half an hour. You're done, I'll see you tomorrow. Otherwise, stay here and ask me more things.
Good day.
You too. Yes, ma'am.
Can you do a question, can you do 39,
From
39 or 41 from 74?
from 7 to 4. These are the ones that already have the integrals in them, right? Yeah. No, that's the later one. Oh, okay, with the S squared and the S in the bottom, right? You wanted 41.
It says use 9.
Okay, so 41 L inverse of 1 over S cubed S minus 1. So what's 9? Let's go back and look. Nine says, whenever I see an S in the bottom, I got to do an integral. So the Laplace inverse of f of s over s is the integral from 0 to t f of, I need a dummy variable, z dz, right? Okay. This is an s cubed. So let's just start with an s and then do an s squared and then do an s cubed. I build them up this way. If I do this, I'm going to do number 40 along the way. So I'm just going to do 39. We're going to do the first one. So when I see 1 over s, s minus 1, I can really think of that as 1 over s minus 1 over s. Right? So this tells me if I want to do the Laplace inverse, I should be doing the integral from 0 to t of, okay, wait a minute. What's the function that is the inverse transform of 1 over s minus 1? So I need you to do that integral. But here's the advantage. That's an easy integral, isn't it? The integral is e to the z evaluated from 0 to t, which is e to the t minus 1. Now to do 40, you think of 1 over s squared s minus 1 as 1 over s minus 1 all over s, isn't it? And this is the thing you just figured out. When I do the inverse, the f of z up here is this function.
So you take the integral of that.
Mhm. This is an iterative process. If I wanted s to the fourth, I'd have to do s squared, s cubed, and then s to the fourth. But fortunately for me, the actual integral itself is not that complicated. Yay! Oh, you're very welcome.
Sorry I was late.